Okay. So, let us start that next week, the new week, which is we will talk about the speech processing application. Mainly I have chosen 3 applications, but there are a lot of applications. So, if time permit, in last week I may cover the speaker and the identification, that the speaker recognition and identification, that part also I covered. So, little bit of GMM I will cover in that topic and vector quantization I will cover. But today let us talk about that this kind of application like speech synthesis and ASR. I have not detail covered that ASR because it itself can take several classes. So, first I covered that speech synthesis applications, that how do we develop the speech synthesis application, what are the pros and cons and everything, and then ASR, then we give out that recent trend in ASR, and then I talk about the action conversion, which is my dream in the research this area. So, a lot of research work is going on in the speech action conversion and speech conversion kind of things. So, we will discuss about all those things in this total week. So, let us talk about the speech synthesis, popularly known as, you know, that TTS, text to speech synthesis system, TTS. Now, if I see the name text to speech, so I can say that I require the machine, let us there is a machine or there is a systems where that system will take input as a text and then output it produce as a speech. Now, if you remember that speech production mechanism, how the speech is produced, that message planning, then that coding and then execution by the vocal tracts and produce the speech. Okay. So, speech production, this part which convert the text to speech, means input text to speech, not only with this production model, but also other text processing model is also important. Because when we say something, it is not just segmental information, it contains the suprasegmental information also. So, if I see the basic block diagram of the speech synthesis, then I can say that text may contain some, so what is the content information in the text? Some linguistic information, non-linguistic information, paralinguistics information. So, there is a linguistic information, there is a paralinguistics information, there is a non-linguistic information. All those information have processed in our mind and executed by this vocal tract system to produce the speech. So, the speech signal, if I say, it contains all the linguistic information, non-linguistic information and paralinguistic information, all those 3 are there in the speech signal. Now, if I want that a system or a machine or an algorithm should develop such that it will take input text and convert it to speech. So, that all kinds of text processings and that signal processings are required in case of development of TTS. So, if we see in the slides, if I show you the text to definition of text to speech software is used to convert word or sentence from a computer documents into audible speech spoken through the computer speakers. So, TTS is nothing but a input is text and output is speech. Application, if I have a good TTS, think about that, it provides the hand free operations, it removes the digital divide. Suppose I cannot, there is a lot of people are there, they cannot read the text, but they can speak, because speech is, you can say, the spoken language, there is a is used for the communication. The person who does not know anything about that written text, he can also speak. If you go to that village area, a lot of people they cannot read, but they can speak. So, what I want, that suppose I have an information stores or text information stores in computer, you see the many forms, many gadgets, newspapers, all are textual information. If I want to disseminate that information to those kind of people who cannot read, then the TTS is must. That means, the machine can read the text and machine can talk, because they understand the spoken version of the language. So, they are comfortable with the spoken version. So, that is called text to speech synthesis and their applications. Now, What typically text to speech synthesis system there? The first block is called text normalization. If you see, if I say open any page, whether it is English, whether it is Bengali, whether it is Hindi, whether it is Marathi, if you read any text passages, there are a lot of normalization is required. Suppose there is some text, content text, so text is running and there is a number 2.35 degrees centigrade. Today's temperature is 22.5 or 2 days temperature is written 35 degree centigrade. When we speak, we never say 35 degree, so we say 35 degree centigrade. So, if you see this information, if I say translate in text, then it is 35 degree centigrade. So, those words, so instead of numerical 35, I have to convert 35 degree centigrade. Similarly, suppose I have a phone number 94320. So, see that here we never said 1, 2, 3. So, 9 lakhs 4,320 we never said. We said 94320 like that if it is phone number. But if it is rupees, then we said rupees, then we say 9 lakhs 4,320. So, lot of text conversion or text normalization is required. Another way is the abbreviation. If you say, if I write doctor, then it has to be pronounced as a doctor. So, there is a lot of short form also. When we pronounced, we complete form we pronounced. So, there is a lot of text normalization is required, unless it will not, when the TTS will produce, but TTS does not know how to produce this. So, this has to be converted in normal text format. So, that is called text normalization. So, if I write the TTS, so there is a input block is text. Text may contain abbreviation, number or suppose 2 by 3 Lalin Saroni, then it should be pronounced as 2 by 3. So, all kind of number abbreviation will be there in the text and that text has to be normalized first, normalization. So, there is a TTS, this is called text normalization. Text has to be normalized first. Once it is normalized, then this goes to text processing unit. How it has to be processed? Because you know text contains some words. So, suppose there is a words and written form of the word and pronunciation form of the word, there is a change. Suppose if you write psychology, the written form and pronunciation form is different. So, I can say there is a requirement text processing which can convert this is called grapheme to phoneme, or even sometime it is written G2P. G2P. What is grapheme? You know that if I say alphabet A, B, C, D, all are grapheme. So, the word written in form of grapheme, that has to be converted to in form of pronunciation string, IPS string. I have said in that first week that I can convert my name in IPS string, that depends on the pronunciation. So, if I write, let us say I write Kolkata, it is a graphemic information. It has to be converted to its pronunciation information, which is Kolkata. This has to be converted. So, this is called grapheme to phoneme conversion. If I write psychology, PC like that way, it has to be written as psychology in pronunciation format, which are the phoneme, you know the number of, if I pronounce psychology. So, so is the first phoneme. So, I write so. If it is palatal so, I write that symbol. If it is dental so, I write that symbol. So, that way all IPS string So, pronunciation string has to be represented by a IPA form. So, I get the pronunciation form of the written word. Okay. So, that is called grapheme to phoneme conversion, details I will come. Then there is a called prosody. If you see, if I say text, if I say tomorrow I will go to Calcutta, there is a prosody is involved. So, prosody which contain the melody of the spoken form. You can say the melody of the spoken form. I never say I will go, like not never said. I said I will go to Calcutta. So, there is a lot of variation in suprasegmental parameters. So, those suprasegmental parameter is not arbitrary. It depends on the syntactic structure of the input text. So, even suprasegmental parameter like pause, duration, F0 and intensity all are varied depending on the syntactic structures of the language. So, last week I will deal about that prosody modeling. So, for prosody modeling, I have to know the syntactic structure of the text, even it can goes to pragmatic structure also. So, I have to process the text using NLP, natural language processing. You know that there is a field called NLP, language processing field. So, I have to use some kind of language processing, so that I can model the prosody which is exists in the spoken form. There is a beautiful example. Suppose if I write I will go to Calcutta, even in written language you see there is a gap in between the word, but if you spoken form there is no gap, there is no word boundary. So, this is continuous spoken form, but we listen some boundary. So, that based on the suprasegmental parameter. So, those are called prosodic word boundary. I will discuss about in prosody modeling that part. So, those called prosodic word boundary. So, some kind of text processing I required to model the speech prosody. So, that modeling required text processing. So, there is a lot of text processing block, two part, mainly one part is convert G to P, grapheme to phoneme conversion. Second part is that some kind of syntactic, semantic and pragmatic information even I have to extract from the text, by which I can model the speech prosody. Once I goes those information, when suprasegmental information and G2P provide me the segmental information. So, once I know the segmental and suprasegmental information, I can use some signal processing algorithm, which is nothing but a synthesis to produce the speech. So, now I can use the synthesis to produce the acoustics waveform. Okay. So, let us discuss about that abbreviation. I have already discussed that you can read many things, that text normalization, that conversion and abbreviation. And there is a, if you know, if you remember, there is a W3C standard. W3C World Wide Web Consortia has a standard under the voice browser activity group, that is called SSML, speech synthesis markup language, speech synthesis markup language. It is nothing but a XML structure which is used to do this kind of job, text normalization, grapheme to phoneme conversion and prosody tag marking. So, when you developed your website, if you all the text, all the written, whatever the written communication is there, if it is tagged using SSML, then it is very easy to synthesize that text when it passed through the synthesizer. So, SSML mainly designed to tag your input text such a way that it can take by a synthesizer engine and process that text, because the text is structured and it is processed and it can produce the better synthesized speech. Okay. So, SSML, there is a lot of tag sets are there. So, if you there is a study is available, you can go through the W3C SSML, you get a lot of document, and that document contain what are the tag sets are there, So, in text normalization they use say as. Suppose if I write 35 degrees centigrade, if I treat this is a word, then I can say for this word, this grapheme, I can say as 35 degrees centigrade. Okay. Then there is a call, I will come to that PLS, that things also there. Abbreviation also, if it is doctors, then I can say it is the grapheme information is doctors. So, I can say the text, the grapheme information is, let us I write GH is a grapheme information. So, I can say grapheme information is doctor dr dot and end of grapheme. Then I can say it can be say as doctor. So, I can define that things. So, if I define that things, SSM will take care about that, or I can develop a dictionary based approach where all the abbreviation their full form will be there. So, once I get the abbreviation, I can run through the dictionary and get the full form. Okay. And that text normalization for number, it is difficult because you do not know where what kind of number system is required, because sometimes if I write 9432091556 is a phone number, then I can say this has to read as 9432091556. We never said like that our that systems. So, but if I write 315 rupees 300 and then we never said 315, we say 315 rupees. So, depending on the context, you have to say what kind of normal text normalization you should apply, that is called text normalization. Now, for G2P, if I details discuss, G2P grapheme to phoneme conversion. So, text to phoneme, or I can say grapheme to phoneme conversion. There is a lot of papers you find that for every language there is several kinds of G2P engines are available, grapheme to phoneme conversion, where the system will take input as a text which is in graphemic information and converted its pronunciation information whatever is there. But for Bangla, if you search in the net grapheme to phoneme conversion for Bangla, you find my paper which is published I think 2008 or 9, that grapheme to phoneme conversion for Bangla, and that is available. You can see that we have developed the TTS engine using that grapheme to phoneme conversion, but sometimes it is very difficult to develop a rule base. So, there is a, you can say there is a lot of approaches are there. Either I can develop the dictionary based approach where I can say I have a two table, here graphemic information, here is pronunciation information. So, there is a W1 word and there will be a pronunciation of W1. So, there will be a W2 word, there will be a pronunciation of W2 words. So, this is one kind of approach which is called dictionary based approach, where I require the pronunciation dictionary of all the words, because I do not know which text will come in my input. So, all the words pronunciation dictionary is required, but you know the words, list of words are infinite. You can say that there is a some kind of combined word. So, you can intelligently develop a root word dictionary and you can form a combined dictionary based on the fly requirement, but combining also there is a problem. Means in Bengali, sometime if the two words are combined, the middle vowels may be pronounced like that. We say Rajputra, that Rajputra, if it is Rajputra, then it is middle vowel is deleted, because Raj is a word and Putra is a word, they are combined, that is why Rajputra is okay. This follow the every word pronunciation, if I combine I get Rajputra, but sometime vowel is not deleted, like it is not Banodaftar, it is not Bandaftar. So, that you have pronounced Banodaftar. So, no, there is a vowel O is added. So, those kind of complexity are there. So, if I have, but the simplest way is that develop a pronunciation dictionary, and or you can say it is called a lookup table in computer programming. So, I can say I have a pronunciation dictionary and I can compare, once I get the grapheme word, I can pick up the pronunciation word from the table. But there is a, if you know the W3C, they have a standard called PLS, pronunciation lexicon specification, PLS, pronunciation lexical specification, pronunciation lexical specification. Details I have already studied the details of PLS of W3C, and we have said that some problem for present PLS. So, this is nothing but a you can say it is required by both speech recognition and speech synthesis, both I will come. So, there is a lot of tag sets are there in PLS standard. If you see, there is a lexeme, that means lexicon is started, then there is a metadata, then lexeme, then grapheme, then phoneme, then alias, and then example. So, they said, but the problem is that they said the some words, if have a multiple pronunciation, use the prefer attribute, choose the correct pronunciation, but it is not always true. Sometimes same word may have different pronunciation, even more than one pronunciation, more than one means more than two also pronunciation, but both pronunciation are a valid pronunciation in that language, it is not dialectic variation. So, we can say I have raised that write that paper, that is called homograph problem, that homograph are the words with same orthography, but different meaning and different pronunciation. Meaning is not important, pronunciation is important. So, homograph, homograph means orthography, grapheme all are same. So, if the if the graphemic representation of the word, let us say it is W1, but it mapped to two pronunciation, one is W1P and maybe the W2P. The pronunciation is 2, maybe 3 pronunciation is the same word can have a 3 pronunciation depending on the context where I use that. Okay. So, that is called homograph. Grapheme is same, but pronunciation is different. In case of Bengali, that I can give you the example in Bengali, if we have Saral, if you know the Bengali script, then you know the Saral may have a pronunciation, two pronunciation, either it may be Sorlo or it may be Saral. So, if it is verb, it is Sorlo, if it is adjective, then it is simple, Saral means simple, then it is Saral. So, all kinds of homograph variation has to be solved. So, it was found that parts of speech information of this word somewhat solve that homograph problem, but not always true. Sometimes same word in case of honorific in nature, maybe pronunciation is some things, and if it is non-honorific in nature, maybe pronunciation is different way. So, those kind of variation may not be, that means semantic variation, there may be a something information that if it is honorific, then the pronunciation will be something like Bangla, tu eta dhar, but tumi eta dharu. So, those kind of pronunciation variation will be there, homograph problem. Then homophone problem, so parts of speech may solve it. You can go through this document, I have already explained it. Then parts of speech, then there is a problem is called that homophone problem. Homophone problem is just opposite, that different orthography has same pronunciation, different orthography has same pronunciation. So, the orthography representation is same, but pronunciation may be have different orthography may be W1 and W2, but the pronunciation is same. Like that right, R-I-G-H-T right, W-R-I-T right in English, both are pronounced as right, but depending on the context I can say which right I have pronounced. Okay. So, those problem will be there in PLS. So, those problem we have proposed some solution, and we have made that paper to submitted this paper to PLS, and they have taken it. So, you can go through the details, papers is available in the net. So, there is a lot of details, examples are there, lot of analysis I have done honorific, then we can say the rule, then there is a dictionary that you can say the morphological information is important, Many country also raise this issue that morphology is important. For Korean also morphology is very important, like that in case of Bangla we have said that finiteness and honorificity information may be required. So, we suggest some kind of morphological analysis for solve the pronunciation problem in Bangla. Okay. So, G2P is not that simple. Many language it may be simple, but in case of Indian language, yes, it is somewhat simple, but Bangla is not that simple. But in case of Hindi, we found that it is little bit of simple compared to other language, because since we have a syllabic language, then the pronunciation whatever we write, we almost pronounce the same, but it is not always true. There may be some variation. In Bengali, there is a lot of variation in written script. In case of English, there is also a lot of variation. So, but if you see, the unfortunately English pronunciation dictionary is available in the net, because that is available. But unfortunately, in Indian language pronunciation dictionary are very rare. You cannot find any pronunciation dictionary of other language. So, there is a very tough challenge to develop that TTS in Indian language. But yes, we have done something for Bangla, some other group also there who are doing for that Hindi, Tamil, Telugu, all languages TTS are right now in there. But the biggest problem is G2P, grapheme to phoneme conversion, which is very important block for the TTS engine. So, W3C has an PLS specification. Yeah, even we can started a community building on that, how do we build communitily the pronunciation dictionary. There is a website, we have developed a web based engine where you can develop the pronunciation dictionary in PLS standard, W3C PLS standard. So, that is website is available in IIT Kharagpur. I think it is run at pedagogy main, like that kind of domain name. So, at the end I will give you that web address where you can use that website to develop your own pronunciation lexicon in W3C format. Okay. Now, there is a other kind of G2P approach also there, the rule based approach, that depending on the grapheme position we can develop some rule, where the rule based approach will pronounce the grapheme to pronunciation conversion will be done. But mostly used approach are hybrid approach, that some simple rule we developed and then we use the dictionary for all exceptional cases. So, that is called hybrid approach. Then once I done that text normalization and G2P, I am not discussing about the text processing required for prosody modeling, because for prosody modeling I will discuss in the next week. The last week I will be details discuss about the prosody modeling of different languages. English there is a prosody modeling. So, there is a lot of prosody model available, Fujisaki command response model, Toby model, all kind of prosody models are there. So, prosody modeling is one of the important issue we will discuss later. So, if text processing for prosody modeling we excluded, then G2P is sufficient. So, I can say the input text will come and then it will converted normalized, and once it is normalization has done, NOR normalization is done, then go to G2P. Once it go to G2P and prosody modeling, the text processing for prosody is combined together called language processing, and then it goes to speech synthesis. So, synthesis there is a lot of formats are there. We will discuss details on synthesis, because it is speech processing class. So, we discuss about the synthesis part, whose output is called the speech. Okay. Now, the one problem is there, that text, I think many of you know the Unicode, I think so, because if I write text TXT, it is in English. So, it is already there in ASCII code system, but if I write in Bengali, Hindi, Tamil, Malayalam, all other languages, those codes are come in Unicode. So, text input text is in the form of Unicode. So, you have to develop, you have to take care about the Unicode processing. So, once Unicode same thing, but every grapheme has a unique Unicode. So, I do not have any problem in processing. So, Unicode processing is there, then based on that you can develop the dictionary, normalization, G2P, all kinds of thing based on the Unicodes of the text. Okay. Then synthesis, there is a lot of algorithms are there in synthesis, articulatory synthesis, parametric synthesis and concatenative synthesis. So, in the next class, I will details discuss about each of the model, articulatory synthesis, parametric synthesis and concatenative synthesis, which is the main part of that TTS engine. So, there is a lot of others approach also there. So, then we will discuss, we show something is available, I can show you, I can listen you, I can show you the voice, all kind of things. Okay? Thank you.